You are listening to Lean Software Development, building better software, faster, and more sustainably. Subscribe to keep up to date on our latest audiobooks. Lean Software Development, building better software, faster, and more sustainably. Chapter 1, The Promise of Lean Software. Why now? The world runs on software. From the moment you wake up and check your smartphone to the complex logistics that deliver goods to your doorstep, software is the invisible engine powering nearly every aspect of modern life. It's in your car, your refrigerator, your financial transactions, and even your pacemaker. This ubiquitous presence means that the quality, speed, and reliability of software have become not just competitive advantages, but fundamental necessities for businesses and individuals alike. Yet, despite its critical role, software development often feels like a perpetual struggle. Projects are frequently plagued by delays, spiraling budgets, and features that, once delivered, don't quite meet user needs. Development teams face the constant pressure of rapid change, accumulating technical debt that slows them down, and sometimes the exhaustion of burnout as they attempt to keep pace with relentless demands. In this landscape of increasing complexity and perpetual pressure, a powerful philosophy, born from the unlikely world of automotive manufacturing, offers a compelling solution: Lean Software Development. What is Lean Software Development? Lean Software Development, LSD, is not just another methodology with rigid rules and prescriptive steps. Instead, it is a philosophy, a set of principles derived from the Toyota production system, adapted for the unique challenges of creating software. At its heart, Lean is about maximizing customer value while minimizing waste. It's about building higher quality software, faster, and in a way that is more sustainable for both the product and the people who build it. Unlike traditional waterfall approaches, which emphasize upfront planning and sequential execution, Lean embraces agility, continuous improvement, and deep customer collaboration. It shifts the focus from simply producing code to creating an efficient flow of value, constantly learning and adapting as the project evolves. Why Lean is more relevant than ever. The principles of Lean have been around for decades, but their application to software development, championed by pioneers like Mary and Tom Poppendike, feels particularly apt today. Here's why: rapid market changes. The digital landscape evolves at a breathtaking pace. Business models can pivot overnight, and customer expectations are constantly reset by new innovations. Lean allows organizations to respond swiftly to these changes, delivering value incrementally rather than betting everything on a single, long-term plan. Complex digital ecosystems. Modern software often involves cloud computing, microservices, artificial intelligence, and distributed teams across different time zones. Managing this complexity requires robust processes that focus on flow, quality, and collaboration, which Lean provides. The user experience imperative. In a crowded market, user experience, UX, is paramount. Lean emphasizes understanding true user needs through fast feedback loops and validated learning, ensuring that what gets built genuinely solves problems for real people. Software is eating the world. As Mark Andreessen famously coined, every company is, at some level, a software company. Whether you're in finance, healthcare, retail, or manufacturing, your ability to innovate and compete increasingly hinges on your software capabilities. Lean provides a framework to build those capabilities effectively. Sustainable development. The pursuit of speed and features often comes at the cost of technical debt and developer burnout. Lean advocates for a sustainable pace, baking quality in from the start, and fostering an environment where teams can thrive and continuously improve, leading to better long-term outcomes for both the product and the people who can benefit from this book. This book is for anyone involved in the creation and delivery of software who seeks a better way. Software developers and engineers. Learn how to write cleaner code, work more efficiently, and contribute more effectively within your team. Team leads and architects. Discover how to foster self-organizing teams, build resilient systems, and guide technical direction with a lean mindset. Project managers and product owners. Understand how to define value, manage flow, prioritize effectively, and connect more closely with customer needs. Business stakeholders and executives. Gain insights into how lean principles can transform your organization's capability to deliver high-quality software predictability, driving business value and competitive advantage. Whether your team is struggling with slow delivery, persistent quality issues, low morale, or simply looking for ways to scale your software efforts more effectively, lean software development offers actionable insights and a powerful philosophical framework for improvement. Structure of the book. Over the next 9 chapters, we will embark on a journey to explore the depths of lean software development. Chapter 2 will take us back to the origins of lean, tracing its path from the factory floor of Toyota to the world of bits and bytes, and clarifying its relationship with agile methodologies. Chapters 3 through 7 will systematically unpack each of the 7 core principles of lean software development. Eliminating waste, amplifying learning, deciding as late as possible, delivering as fast as possible, empowering the team, building integrity in, and seeing the whole. Each principle will be explained with examples and practical applications within the software context. Chapter 8 will shift to practical implementation, offering strategies and roadmaps for integrating lean principles into your team or organization, regardless of its current size or maturity. Chapter 9 will delve into specific tools and practices that embody lean, such as value stream mapping, Kanban, test-driven development, and continuous delivery, showing how they enable the principles. Finally, Chapter 10 will look beyond the immediate application, discussing how to sustain a lean culture over time, acknowledge common challenges, and peer into the future of software development in a lean-enabled world. Before we dive into the specific principles, let's turn to where it all began, understanding the roots that make lean software development such a robust and enduring approach. Chapter 2, Roots of Agility. From Toyota to software. To truly grasp the power and nuance of lean software development, we must embark on an unexpected journey. One that begins not in Silicon Valley or a bustling tech startup, but on the factory floors of post-World War II Japan. The principles that revolutionize software today have their surprising origins in a manufacturing system designed to overcome scarcity and competition, the Toyota Production System. The Toyota Production System, TPS. The origin story. In the aftermath of World War II, Japan was a nation of scarcity, desperate to rebuild its economy. Its automotive industry, in particular, was dwarfed by the massive production volumes of American manufacturers like Ford and General Motors. Toyota, led by visionaries like Taiichi Ohno and Eiji Toyota, faced a formidable challenge: how to compete without the vast resources and economies of scale enjoyed by their Western rivals. Their answer became known as the Toyota Production System, TPS. Instead of mass production, which was efficient for high volume but struggled with variety and responsiveness, Toyota focused on eliminating waste and maximizing flow. They didn't produce cars in huge batches. They manufactured only what was needed, when it was needed. This seemingly simple idea required a radical rethinking of every step in the production process. Core to TPS were principles like just-in-time, JIT, ensuring that parts and materials arrived at the assembly line precisely when they were needed, not too early, avoiding excess inventory, a form of waste, and not too late, avoiding delays. Jidoka, automation with a human touch, building quality directly into the process. If a defect was detected, the production line would stop immediately, allowing the problem to be fixed at its source, preventing defective products from moving further down the line. This empowered workers to halt production, a revolutionary concept at the time. Kaizen, continuous improvement, a relentless pursuit of small, incremental improvements by everyone, every day. Workers were encouraged to identify problems, experiment with solutions, and share their learnings. This fostered a culture of constant learning and adaptation. At the heart of TPS was the obsessive focus on identifying and eliminating muda, the Japanese term for worthless waste. Ono identified several types of waste, which we will deeply explore in Chapter 3, but their combined effect was to slow down production, consume resources, and ultimately, drain profit and customer value. TPS sought to remove not only muda, but also mura, unevenness, and muri, overburden, aiming for a smooth, balanced, and sustainable workflow. Lean manufacturing takes hold. The success of TPS was undeniable. By the 1980s, Western manufacturers began to notice Toyota's superior quality, efficiency, and responsiveness. A landmark study by the Massachusetts Institute of Technology, MIT, culminating in the 1990 book, The Machine That Changed the World. The story of lean production by James Womack, Daniel Jones, and Daniel Ruse formally introduced the concept of lean production to the world. This book demystified TPS, dubbing it lean, because it used less of everything, less human effort, less manufacturing space, less investment in tools, less engineering time, and less time to develop new products. The term lean soon became synonymous with a comprehensive system for eliminating waste and creating value. And its principles began to spread beyond automotive into various industries from healthcare to logistics. From assembly lines to code lines, the transition to it. For years, the application of lean principles seemed confined to processes involving physical goods. Software, being intangible, complex, and driven by knowledge work rather than repetitive assembly, appeared fundamentally different. How could you apply the concept of inventory or an assembly line to lines of code? The breakthrough came through the intuitive understanding and pioneering efforts of individuals like Mary and Tom Poppendieck. In their seminal works, including Lean Software Development, an Agile Toolkit, 2003, and Implementing Lean Software Development, From Concept to Cash, 2006, they meticulously bridged the gap. They recognized that while software development doesn't involve physical parts, it contains analogous forms of waste, inventory, and flow challenges. For example, inventory in software, partially finished features, unreleased code, overloaded backlogs, and comprehensive but unused documentation are all forms of inventory work that has been done but isn't yet delivering value. Flow in software. The journey of a feature from idea to deployed, used software is a value stream analogous to an assembly line. Bottlenecks, handoffs, and delays in this stream impede flow. Quality in software. Just as a flawed physical product costs money to rework or recall, bugs and defects in software lead to expensive fixes, unhappy users, and reputational damage. The Poppendieck's eloquently translated the 7 core tenets of lean production into powerful principles for software development, demonstrating that the underlying philosophy of continuous improvement, waste elimination, and value focus was highly applicable, despite the differences in domain. Lean's relationship with Agile. It's impossible to discuss lean software development without mentioning Agile. For many, the terms are often used interchangeably, or lean is seen as a subset of Agile. However, it's more accurate to view them as complementary and deeply interconnected. The Agile Manifesto, 2001. This groundbreaking document, penned by 17 independent software practitioners, articulated 4 core values and 12 supporting principles for Agile software development. These included valuing individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. Shared values. Lean and Agile share a profound commitment to adaptability, customer centricity, continuous delivery, and empowering teams. Many of the practices associated with Agile, like Scrum, Kanban, XP practices, inherently align with lean principles. For instance, an Agile sprint review amplifies learning, while daily stand-ups and limited work in progress, WIP, aim to improve flow and reduce waste. Lean as the big picture. One way to differentiate is to see lean as the broader, overarching philosophy, the why behind many effective Agile practices. Agile provides a fantastic toolkit and mindset for how to develop software in an iterative and adaptive way. Lean provides the deeper insight into what to optimize, value stream, how to think about quality built in, and where to focus efforts, waste elimination, across the entire software development lifecycle, extending beyond just the development team to the entire organization and even the market. In essence, Lean provides the strategic foundation and the systemic view that can supercharge Agile implementation, preventing it from becoming a superficial adherence to rituals without understanding their underlying purpose. Having understood where lean comes from and how it translates to the world of software, we are now ready to dive deep into its foundational elements. The 7 principles of lean software development. These principles, when understood and applied, form the bedrock for building better software, faster, and more sustainably. We begin with the most fundamental one, the relentless pursuit of eliminating waste. Chapter 3, the first principle. Eliminating waste, muta. If there is one concept central to lean, it is the uncompromising pursuit of waste elimination. Taiichi Ohno, the architect of the Toyota production system, saw waste, or muta, as anything that consumes resources without adding value for the customer. In the world of software development, this principle is equally, if not more, critical. Our goal is to scrutinize every activity, every process, and every line of code to ask, does this truly add value for our end user? If the answer is no, it's likely waste, and it needs to be minimized or removed. Defining value in software. Before we can talk about eliminating waste, we must clarify what value means in the context of software. Unlike a physical product where value might be tangible features or quality materials, software value is often more abstract. In Lean, value is defined by what the customer is willing to pay for or what solves a problem for them. Features versus solutions. A long list of features might seem valuable, but if users only utilize a fraction of them, the rest is, in effect, waste. True value lies in solving a user's problem, making their life easier, or fulfilling a critical need. Stakeholder perspective. While the end user is paramount, value can also be defined by internal stakeholders. A feature that streamlines an internal process, improves data accuracy, or enhances security. The key is that it contributes to a goal that ultimately benefits the end customer or the organization's mission. Any activity or output that does not directly contribute to this defined value is a candidate for elimination. The 7+1 wastes in software development. Inspired by Ohno's original 7 wastes, lean software development adapts these categories to the unique characteristics of code and knowledge work. Let's explore them. Partially done work inventory. Description. Features that are coded but not tested, tested but not deployed, or sitting in a bloated backlog. It's work that has consumed resources but isn't yet delivering value to the customer. Just like excess inventory on a factory floor ties up capital and space, partially done software ties up effort, hides defects, and prevents fast feedback. Examples: unmerged feature branches, features awaiting integration testing, unvalidated user stories in a long product backlog, detailed documentation for a feature that might never be built. Impact. Delays feedback, increases complexity, hides problems, and ties up resources. Extra features overproduction. Description. Building functionality that users don't need, won't use, or could easily live without. This is often called gold plating or feature creep. It's the software equivalent of manufacturing products no one wants to buy. Examples: implementing every conceivable customization option, building complex reports that no one reads, adding advanced settings before basic functionality is stable. Impact: wasted development effort, increased complexity, higher maintenance costs, and delayed delivery of core value. Relearning motion waiting. Description. This waste manifests as the time spent searching for information, recreating lost knowledge, or waiting for clarification. It's the effort expended simply to get ready to do the work. Examples: poor documentation or none, knowledge silos, only one person knows a system, fragmented communication, searching for the right version of a file, setting up development environments from scratch repeatedly. Impact: reduced productivity, frustration for developers, delays. Handoffs, transportation. Description: transferring work or information from one person or team to another, especially when it involves different roles, tools, or physical locations. Each handoff is an opportunity for miscommunication, delay, and loss of context. Examples: throwing code over the wall from development to QA, passing requirements between business analysts and developers, separate design teams handing off mock-ups to front-end developers, manual deployment processes between dev and operations. Impact: delays, errors, misinterpretations, reduced ownership, and friction between teams. Delays waiting. Description: Any amount of time when work is stopped, blocked, or not actively progressing. It's the wasted time between activities. Examples: waiting for approval, waiting for a server environment, waiting for test data, waiting for another team to complete a dependency, waiting for a bug fix from a different team, code reviews sitting for days. Impact: stalled projects, missed deadlines, high costs due to idle resources, loss of flow and momentum. Defects, description, errors, bugs, or quality issues that require rework. This is perhaps the most obvious form of waste. Examples: bugs found during testing, security vulnerabilities, performance bottlenecks, incorrect feature implementations, regressions. Impact: rework effort, increased costs, missed deadlines, reduced customer satisfaction, damage to reputation. Task switching, overprocessing motion. Description: constantly jumping between multiple, unrelated tasks. While previously called overprocessing, doing more work than necessary to produce a good outcome, in software, this often manifests as the mental overhead of context switching. Each switch incurs a cognitive cost. Examples: developers working on 3 different projects simultaneously, frequently interrupting work for urgent requests, reacting to every incoming email or chat message immediately. Impact: reduced focus, increased errors, longer overall completion times for individual tasks, mental fatigue. Underutilized talent, intellectual capital. The +1, description. This crucial 8th, waste, is about not leveraging the full potential, creativity, and problem-solving abilities of your team members. It's a waste of human capital. Examples: micromanaging talented individuals, ignoring developer suggestions, lack of cross-training, assigning repetitive, mind-numbing work exclusively without variation. Impact: demotivation, disengagement, missed opportunities for innovation, lower quality solutions. Identifying waste, value stream mapping, VSM. One of the most powerful tools for identifying waste is value stream mapping, VSM. It's a visual technique used to understand and analyze the flow of materials and information required to bring a product or service to a customer. In software, it helps visualize the entire process from the initial idea or customer request to the final deployment and customer usage. How to conduct a basic VSM exercise for software. Define the scope. Choose a specific product, feature, or service to map. Identify the steps. Map out every single step work goes through, from concept inception, e.g., customer requests feature, to delivery, e.g., feature deployed to production and used by customer. Include all activities, even those that seem minor, e.g., waiting for code review, filling out deployment form. Collect data for each step. Process time, PT. The actual time spent doing value-adding work in that step, e.g., developer coding for 4 hours. Lead time, LT. The total time a unit of work, e.g., a feature, spends in that step, including waiting, handoffs, and actual work, e.g., 2 days for code review. Queue time, QT. The time a unit of work waits before being processed at that step. Quality, any defects or rework associated with that step. Visualize, draw the map using swim lanes for different departments or roles. Use symbols to denote processes, data, queues, and communication. Calculate total times. Sum up all the process times for the value-added time. Sum up all the lead times for the total cycle time. The difference highlights the dominant presence of waste, waiting, handoffs, etc. Identify waste and bottlenecks. Look for long waiting times, excessive handoffs, loops for rework, and points where work piles up. These are your opportunities for improvement. Brainstorm solutions. Based on the identified waste, brainstorm ways to reduce or eliminate it. Example: a VSM might reveal that while coding a feature takes 3 days, process time, the total time from idea to production is 35 days, lead time. With 20 days spent waiting for reviews, 5 days on environment setup, and multiple handoffs causing rework. This immediately highlights where the true waste lies. After this revelation, the team might implement a strict work in progress limit in their code review process to reduce waiting and invest in automated environment provisioning to eliminate that delay. This focus on flow over individual utilization dramatically shrinks the overall lead time. Strategies for waste reduction. Once waste is identified, the focus shifts to elimination. Here are some general strategies. Limit work in progress, WIP. Don't start more than you can finish. Finishing what's started rather than starting more is the key to faster delivery and less partial work. This is often implemented through Kanban board limits, as we will explore in Chapter 9. Focus on minimum viable products, MVPs. Deliver the smallest possible increment of value to users, get feedback, and then iterate. This reduces the risk of building extra features. Automate everything feasible. Testing, deployment, infrastructure setup, and repetitive tasks should be automated to reduce manual effort, delays, and defects. Improve communication and collaboration. Foster cross-functional teams, co-location if possible, and tools that facilitate immediate communication to reduce handoffs and relearning. Invest in quality assurance early and continuously. Shift-left testing, TDD, CI, and automated testing are crucial to building quality in and minimizing defects throughout the process, rather than trying to test quality in at the end. By diligently applying these definitions and strategies, the team can convert the abstract idea of waste into concrete actions that streamline their process, reduce frustration, and ultimately, deliver more value faster. This dedication to stripping away the non-essential allows us to accelerate learning, which is the subject of our next chapter. Chapter 4. The second principle, amplifying learning. If eliminating waste is about doing things more efficiently, then amplifying learning is about doing the right things in the first place and getting better at doing them over time. In a domain as complex and unpredictable as software development, learning isn't just an advantage, it's a fundamental necessity. Every line of code, every feature shipped, and every bug squashed holds a lesson, and a lean approach ensures those lessons are systematically captured and applied. The inherent uncertainty of software. Unlike manufacturing a physical product, where the end result is a known commodity, e.g., a specific car model, software development deals with significant inherent uncertainty. Requirements change, user needs evolve, market conditions shift, and new technologies emerge, often rendering initial requirements obsolete before the software is even built. Technology evolves. Programming languages, frameworks, and infrastructure platforms are constantly advancing, requiring continuous adaptation and learning from developers. User needs are discovered. Users often don't truly know what they want until they see and interact with a working product. Initial assumptions can be wildly off the mark. This context stands in stark contrast to the more predictable, repeatable processes of a factory floor. In software, we are constantly solving novel problems, and our understanding of the problem itself often improves throughout the development process. This necessitates a build-measure-learn feedback loop, emphasizing rapid experimentation and iterative improvement. Learning at multiple levels. Amplifying learning isn't just about individual developers acquiring new skills, although that's important. It's a multifaceted endeavor that occurs at various levels. 1. Customer learning. Understanding what users truly need. This is arguably the most critical level of learning. Often, the biggest waste in software development isn't poorly written code, but perfectly written code for the wrong product. Lean startup principles. Inspired by Eric Rice's The Lean Startup, this approach champions iterative product development with a strong emphasis on validated learning. Instead of building a full-blown product, teams formulate a hypothesis. We believe users need X. Build a minimum viable product, MVP, the smallest possible feature or product that can test that hypothesis. Measure user behavior. Collect data on how users interact with the MVP, analytics, A/B tests, surveys. Learn and adapt. Analyze the data to validate or invalidate the hypothesis, then pivot, change direction, or persevere, continue building based on validated learning. User research and feedback. Direct engagement with users through interviews, usability testing, focus groups, and continuous feedback channels. Analytics and telemetry. Using data from live systems to understand user behavior, feature adoption, and areas of confusion or difficulty. A/B testing. Running experiments where different versions of a feature or design are presented to different user segments to see which performs better. 2. Technical learning, improving code, architecture, and tools. This level focuses on the craftsmanship of software itself. How can we make our systems more robust, scalable, and maintainable? Experimentation, setting aside time for spikes, prototypes, or proofs of concept to explore new technologies, evaluate solutions, or test architectural approaches before committing to a larger build. Technical retrospectives, dedicated sessions to reflect on technical decisions, code quality, and the effectiveness of development practices. Postmortems/blameless postmortems. After an incident or outage, a thorough analysis of what went wrong, focusing on systemic issues and lessons learned, rather than assigning blame. This fosters a culture of learning from mistakes. Code reviews, not just for finding bugs, but for spreading knowledge, identifying design improvements, and maintaining coding standards. Shared ownership, when multiple team members work on different parts of the system and review each other's code, collective technical understanding grows. 3. Process learning, optimizing the development workflow. This is about improving how the team works together to deliver software. Retrospectives, team level, regular meetings where the team reflects on the past iteration, e.g., sprint, identifies what went well, what could be improved, and creates actionable plans for the next iteration. Key questions. What should we start doing? What should we stop doing? What should we continue doing? Key performance indicators, KPIs, and metrics. Tracking metrics like lead time, cycle time, throughput, and defect rate can provide objective data to identify bottlenecks and measure the impact of process changes. Process experimentation, trying out new tools, new ways of collaborating, or different meeting structures, and then evaluating their effectiveness. Fast feedback loops are key. The common thread, uniting all forms of learning in Lean, is the need for fast feedback loops. Learning only occurs when there's an opportunity to act on new information. The longer the delay between an action and its outcome, feedback, the harder it is to learn and correct course. Automated tests provide immediate feedback on code correctness and regressions, giving developers confidence to make changes. Continuous integration, CI, regularly merging code ensures early detection of integration issues, providing rapid feedback on compatibility. Frequent, small deployments. Getting software into users' hands quickly allows for immediate user feedback. Direct user interaction, facilitating conversations between developers and end users or involving users in demonstrations. Telemetry and monitoring, real-time data on how systems are performing in production and how users are interacting with them. Consider the analogy of learning to ride a bicycle. If you had to wait a week between each attempt to see if you fell, you'd learn incredibly slowly. But with immediate feedback, falling versus balancing, you adjust quickly. Software development is no different. Creating a learning culture. Amplifying learning requires more than just tools and processes. It demands a specific organizational culture. Psychological safety. Teams must feel safe to admit mistakes, ask dumb questions, and experiment without fear of punishment. This is fundamental for genuine learning. If every error is met with blame, teams become defensive and hide problems, preventing systemic learning. Knowledge sharing. Encourage pair programming, mob programming, internal presentations, and well-maintained wikis to spread knowledge and avoid silos. Dedicated learning time. Some organizations allocate a portion of a team's time, e.g., 10 to 20%, for learning, experimentation, or addressing technical debt, recognizing that investment in learning pays long-term dividends. Cross-training, enabling team members to learn skills outside their primary role, making them more versatile and resilient. Case study, consider PivotCo, a young startup developing a social networking app. Their initial hypothesis was that users wanted a hyperlocal event discovery feature. They spent 2 months building a comprehensive version of this, only to find in beta testing that engagement with the feature was minimal. Users were, however, interacting heavily with a simple chat with friends function they had included as an afterthought. Recognizing this, PivotCo adopted a lean approach. For their next feature, they formulated a new hypothesis. Users want a more integrated group messaging experience. Instead of building a full solution, they delivered an MVP, a basic group chat with photo sharing, within 2 weeks. They then diligently tracked usage, conducted user interviews, and analyzed data. The usage data was overwhelmingly positive for the group chat. Learning from this rapid experimentation, they pivoted their development focus, doubling down on the group messaging features and scrapping further development on the event discovery. This swift, data-driven learning saved them months of wasted development, effort on a feature nobody truly wanted, and allowed them to build out the functionality that resonated with their users, contributing significantly to their eventual success. Amplifying learning empowers teams to navigate the inherent uncertainties of software development. It transforms mistakes into opportunities for growth and ensures that every effort contributes to a deeper understanding of both the problem and the solution. This understanding, in turn, allows us to make better decisions, particularly when it comes to when to make them, which leads us to our next set of principles: deciding as late as possible and delivering as fast as possible. Chapter 5. The third and fourth principles: deciding late, delivering fast. These two principles might seem contradictory at first glance. How can you decide late and deliver fast? Yet, in the world of lean software development, they are powerful complements. They constitute a pragmatic approach to managing uncertainty, maximizing flexibility, and ensuring that development efforts are constantly aligned with current market realities and user needs. Together, they create a virtuous cycle that reduces risk and accelerates value delivery. Principle 3. Decide as late as possible, the last responsible moment. Traditional software development often insists on upfront, detailed planning. Teams are expected to define every requirement, design every component, and estimate every task before writing a single line of code. The assumption is that comprehensive early planning reduces risk. However, in a volatile and uncertain environment, this approach often has the opposite effect. The problem with early commitments: when you commit to rigid plans too early, you make decisions based on the least amount of information. As a project progresses, new information emerges: user feedback, technological breakthroughs, competitor actions, or even changes in business strategy. This fresh intelligence can reshape the landscape. If you've already committed to a fixed, unchangeable plan, changing course becomes incredibly expensive, if not impossible, leading to developing features that are no longer relevant or desired by users, accumulating technical debt by forcing old architectures to fit new, unforeseen requirements, increased rework, frustration, and eventual project failure. Concept of optionality. Lean encourages maintaining optionality, the right or ability to make a choice, for as long as possible. This means delaying critical, often irreversible, decisions until the very last moment, when the cost associated with not making the decision, e.g., blocking other work, missing a market opportunity, or increasing risk, becomes greater than the benefit of waiting for more information. This pivotal point is often referred to as the last responsible moment. Not procrastination, this is crucial. Deciding late is not about putting things off or being indecisive. It's a deliberate, strategic choice to wait until the maximum amount of relevant information is available to make the best possible decision. It requires understanding the consequences of deferral and knowing when the opportunity cost of waiting outweighs the benefit of further data gathering. Deferring irreversible decisions. Focus on delaying decisions that are difficult or impossible to undo without significant cost. These often include major architectural choices, e.g., committing to a specific database technology, cloud provider, or foundational framework. Committing to a specific feature's complete implementation before thoroughly validating its need with real users. Rigid, long-term roadmap commitments far into the future, which might prematurely lock in a path that later proves suboptimal. Example: instead of choosing a specific microservice framework at the very beginning of a project, a team might initially build a prototype with a more generic, framework-agnostic setup. This allows them to defer the final framework decision until they have a clearer understanding of performance needs, integration complexities, and potential scaling challenges derived from actual usage. Similarly, a product team might iterate on core user flows with interactive mockups and prototypes, deferring the final, labor-intensive UI design decisions until user experience has been thoroughly validated. avoiding wasted effort on unneeded design elements. Principle 4, deliver as fast as possible. While deciding late gives you flexibility and reduces the risk of building the wrong thing, delivering fast ensures that you quickly gather the feedback needed to make those informed decisions. Speed in this context is not about rushing, cutting corners, or sacrificing quality. It's about optimizing flow and throughput so that value reaches the customer swiftly and continuously. Why speed matters: faster feedback. The quicker users interact with your software, the faster you learn whether it meets their needs, has usability issues, or requires adjustments. This feeds directly back into the amplifying learning principle, Chapter 4. Reduced risk. Smaller, more frequent deliveries isolate potential issues, making them easier to identify, diagnose, and fix. It's far less risky to deploy a small, incremental change than a massive, infrequent one. Earlier return on investment, ROI. Getting features into users' hands sooner means they can start generating value, capturing market share, or creating revenue earlier. Competitive advantage. Rapid iteration cycles allow you to outmaneuver competitors in a fast-paced, digital market by adapting and innovating more quickly. Team motivation. Seeing tangible results delivered frequently is a powerful motivator for development teams, fostering a sense of accomplishment and purpose. Flow and throughput. Delivering fast means optimizing the entire value stream, as discussed in Chapter 3, regarding waste for speed. This isn't about individual developers working faster. It's about systematically removing bottlenecks, reducing handoffs, and minimizing delays within the end-to-end process. The goal is a smooth, continuous flow of work. Small batches. A cornerstone of delivering fast is working in small batches. Instead of building large, complex features that take months to complete, break them down into the smallest possible vertical slices of functionality that can be delivered independently and provide tangible value to the user. Reduces work in progress, WIP, and risk. Smaller units of work are easier to manage, test, and deploy. The impact of an error is contained. Facilitates faster feedback. Each small increment can be released, quickly gather user feedback, and inform subsequent development. Simplifies debugging and deployment. With fewer changes in each deployment, it's significantly easier to pinpoint the source of issues if they arise after a release. Example: instead of building an entire user registration system with all bells and whistles, deliver a basic email password registration first. Once that's live and validated, add social media login as a separate, small batch feature. Then perhaps a password recovery mechanism. Each step delivers value incrementally. Continuous delivery deployment, CD, as an enabler. Modern software development heavily relies on continuous delivery, CD, and continuous deployment, CDP, to achieve pervasive speed and release reliability. These automated pipelines are essential enablers of the deliver fast principle. Continuous delivery. This practices means your software is always in a deployable state. It's the ability to get all types of changes, new features, bug fixes, configuration updates, internal architectural improvements, into production or into the hands of users safely, quickly, and sustainably. Continuous deployment. An extension of CD, where every change that passes a predetermined set of automated tests is automatically deployed to production without human intervention. This represents the fastest possible delivery cycle. Automated release pipelines. Both CD and CDP rely on a highly automated process for building, testing, and ultimately deploying software to production. This drastically reduces the time and effort required for releases, making them routine, low-risk events rather than stressful, infrequent big bangs that monopolize team energy and time. The done increment. In Lean, done means the software is shippable. It's not just coded and tested. It's integrated, potentially deployed, and ready to be used by customers. This clear definition clarifies expectations, drives quality, and avoids the waste of partially done work discussed in Chapter 3. The synergy of deciding late and delivering fast. These two principles create a powerful synergy that forms the backbone of Lean's approach to managing uncertainty and rapid change. Deciding as late as possible maximizes flexibility, allowing you to incorporate the latest information, insights, and validated feedback into your critical decisions, ensuring they are truly informed and relevant. Delivering as fast as possible ensures that you get that latest information and feedback quickly, enabling you to make those informed decisions at the right moment, the last responsible moment. Without fast delivery, deciding late becomes procrastination, as you lack the timely information required to make an informed decision. Without strategically deferring decisions, fast delivery might just mean quickly building the wrong thing, resulting in immense rework and waste. Together, they form a robust strategy for navigating uncertainty and consistently delivering valuable software that evolves with customer needs and market dynamics. Practical example: consider an e-commerce company building a new checkout flow. Instead of spending extensive months planning every detail and then launching a single, massive update, a decide early, deliver slow approach, they adopt a lean strategy. They initially launch a very basic, functional one-page checkout, a small batch delivered fast. They immediately begin to analyze user behavior, conversion rates, and abandonment points using built-in analytics. Based on this real, empirical data, they prioritize and incrementally add features like guest checkout, a wider range of payment methods, or loyalty program integration. One small, vertical slice at a time, deciding late, based on validated learning. This iterative approach allows them to quickly capture value from their basic functionality, continuously improve based on concrete user feedback, and adapt to changing user preferences or competitive offerings without ever wasting effort on unneeded or poorly designed features. By strategically delaying commitments and relentlessly pursuing rapid, small batch delivery, organizations can stay nimble, reduce existential product risk, and maximize their ability to produce software that truly resonates with their users and the market. But for any of this to happen effectively, the teams building the software must be truly empowered, and quality must be an integral part of the process, built in from the ground up, which brings us to our next set of principles. Chapter 6, the fifth and sixth principles, empowering teams, building integrity. In the intricate dance of software development, where complexity and constant change are the norms, the human element and the inherent quality of the product cannot be understated. Lean software development recognizes this by dedicating two pivotal principles. One focusing on the invaluable asset of human talent, empowering the team, and the other on the indispensable promise of quality, building integrity in. These principles are deeply intertwined. Empowered teams naturally take greater ownership of quality, while robust quality practices liberate teams to innovate more freely. Principle 5. Empower the team. At the heart of Lean is the powerful belief that the people closest to the work are often in the best position to identify problems, propose solutions, and make the most effective decisions. This contrasts sharply with traditional command and control management structures, where decisions flow top-down and execution is strictly monitored. Lean shifts management's role from dictating to facilitating, from controlling to coaching, beyond management to leadership. Leaders in a lean environment act as servant leaders. Their primary role is to set the vision, clearly articulate the what and the why, providing a compelling purpose, but leaving the how to the teams. Remove roadblocks, actively identify and eliminate organizational, technical, or interpersonal obstacles that prevent teams from doing their best work. This often involves navigating organizational politics and securing necessary resources. Provide resources and support. Ensure teams have the necessary tools, training, information, and a psychologically safe environment to experiment and learn. Foster a culture of trust. Empowerment rests on a foundation of trust. Leaders must demonstrate trust in their teams to make good decisions, learn from their mistakes, and innovate. Self-organizing teams. Lean thrives on the concept of self-organizing teams. These are groups of individuals who collectively have the authority and responsibility to determine the best way to achieve their objectives. They decide how to split tasks, how to approach problems, and how to continuously improve their own processes. Why autonomy works. When teams have autonomy, they feel a stronger sense of ownership and accountability for their work. This leads to higher motivation, increased creativity, better problem-solving, and more innovative solutions than dictated approaches. Increased morale and retention. People are more engaged, satisfied, and likely to remain with an organization when they have a say in their work and feel trusted to shape their destiny. Cross-functional teams. To reduce handoffs and improve flow, a waste we explored in Chapter 3, Lean advocates for cross-functional teams. These teams possess all the diverse skills necessary to take a piece of work from concept to delivery, encompassing development, testing, design, and sometimes operations or product ownership functions. Benefits: reduced communication overhead, faster delivery cycles due to fewer dependencies, shared ownership of the entire value stream, holistic understanding of the product, and collective problem-solving. Example: instead of separate dev, QA, and operations teams, a cross-functional team might include software engineers who also write automated tests, collaborate with designers, and even manage their own deployments, reducing external handoffs and accountability gaps. Mastery, autonomy, purpose. Daniel Pink, in his influential book, Drive, argues that these three elements are powerful intrinsic motivators for knowledge workers. Lean aligns perfectly with this: autonomy, empowering teams to decide how they deliver their work within a broader strategic direction. Mastery, encouraging continuous learning, skill development, and craftsmanship in their chosen field. Purpose, connecting team members' daily work directly to customer value and overarching organizational goals, as emphasized by Seeing the Whole in Chapter 7. DevOps and Site Reliability Engineering, SRE. These contemporary movements perfectly embody the principle of empowered teams taking end-to-end ownership. DevOps merges development and operations functions, breaking down traditional silos and empowering development teams with operational responsibilities and tools. SRE, as practiced at Google and elsewhere, focuses on the reliability and scalability of systems, often by empowering development teams with the mandate and tools to ensure the operational health of their own services. They represent the ultimate trust in teams to build, deploy, and operate the software they create. Principle 6. Build integrity in. The traditional approach to quality often involves a dedicated quality assurance (QA) team at the end of the development cycle, acting as a gatekeeper. Lean argues that quality cannot be inspected in at the end. It must be built in from the very beginning at every step of the process. This fundamental shift in mindset transforms quality from a final check to an inherent attribute and continuous responsibility of everyone involved. Concept of integrity. The Popendijks describe integrity as having two crucial dimensions: perceived integrity, how well the product meets the user's overall needs and expectations. This goes beyond mere functional correctness to include usability, performance, reliability, and the overall emotional connection or feel of the product. Does the product feel right and delightful to the user? Conceptual integrity, the cohesiveness, consistency, and clear vision in the design and architecture of the software. Is the system well-structured, maintainable, understandable, and does it adhere to a consistent design philosophy, even as it grows and evolves? Building integrity means continuously addressing both these dimensions throughout the entire development lifecycle. Practices for building integrity in test-driven development, TDD. A discipline where automated tests are written before the corresponding production code. This red-green refactor cycle forces developers to think about the desired behavior and edge cases up front, resulting in cleaner, more robust, and testable code. It's a continuous, rapid feedback loop on code correctness and design. Pair programming, mob programming, two or more developers working together on the same piece of code at one workstation. This provides immediate, continuous code review, rapid knowledge sharing, and early bug detection, dramatically improving code quality and team cohesion. Code quality practices, refactoring, continuously improving the internal structure of existing code without changing its external behavior. This is essential for maintaining conceptual integrity, managing technical debt, and ensuring long-term maintainability. Static analysis, automated tools that analyze code for potential errors, style violations, security vulnerabilities, and adherence to coding standards without executing the program. Clean code principles. Adhering to universally accepted standards for readability, simplicity, and maintainability, ensuring that code is easy to understand and modify by anyone on the team. Continuous integration, CI. Developers frequently merge their code changes, at least daily, often multiple times a day, into a shared main branch. An automated build server immediately compiles the code and runs a comprehensive suite of automated tests. This quickly detects integration issues or regressions, ensuring the codebase is always in a healthy, working, and potentially releasable state. Automated testing, comprehensive. Investing heavily in automated tests at all levels: unit, integration, functional, performance, security, and user interface, UI tests. This allows for rapid and reliable verification of functionality, catching defects early in the development cycle where they are cheapest to fix. Behavior-driven development, BDD. An extension of TDD that focuses on defining tests around the behavior of the system from the perspective of its users or stakeholders. It often uses a clear, simple, human-readable language, such as Gherkin syntax. Given context, when event, then outcome, to specify requirements, fostering a shared understanding across developers, testers, and product owners. Definition of done, do, D. A clear, agreed-upon checklist that a feature or user story must meet before it can be considered done. This often includes coding complete, passing automated tests, successful deployment to a staging environment, updated documentation, and meeting specific performance criteria, ensuring no essential steps are skipped. The interconnection, empowered quality. The link between these two principles is profound and mutually reinforcing. When teams are truly empowered, they take greater intrinsic ownership of their work, including its quality. They are more likely to adopt practices like TDD, pair programming, and continuous integration, because they understand the intrinsic benefits for themselves, their colleagues, and the product's long-term viability. They see quality not as an imposed burden, but as a source of pride and efficiency. Conversely, having robust quality practices, integrity built in, provides teams with the confidence to move faster, experiment more boldly, and refactor code without fear, knowing that a comprehensive safety net of automated tests and continuous checks will catch errors early. This dynamic allows for a virtuous cycle of rapid delivery, learning, and sustained high quality. Case study: consider Reliable Tech, a company that historically had a large, separate QA department responsible for finding bugs just before release. This created long testing cycles, numerous bug-fixing sprints, and often friction between development and QA. By adopting Lean, Reliable Tech decided to shift left on quality. Their first step was to empower cross-functional feature teams. Each team was given the autonomy to decide on its internal development practices, and they received training in TDD, BDD, and building robust CI/CD pipelines. The old QA role evolved. Former QA engineers became specialists embedded within development teams, acting as quality coaches and helping write automated tests. During development, engineers practiced TDD, writing tests before code. They paired frequently, catching design flaws and bugs collaboratively. Code changes were continuously integrated, triggering a comprehensive suite of automated tests that ran within minutes. If a test failed, the team was immediately alerted, and fixes were implemented within hours, not weeks. The result? While the initial investment in training, automation, and cultural change was significant, Reliable Tech experienced a dramatic reduction in post-release defects. Instead of large, risky releases every few months, they could now deploy small, tested features multiple times a week. Team morale soared as the development and quality functions became one cohesive unit, collectively responsible for the integrity of their product. This transformation was only possible because they trusted their empowered teams to take responsibility for building integrity in. By fostering an environment of trust and autonomy, and embedding quality into every aspect of software creation, lean organizations build not just great products, but also highly effective, satisfied, and sustainable teams. This holistic view of product and process sets the stage for the final lean principle, seeing the whole. Chapter 7, the seventh principle, seeing the whole. The final principle of lean software development, seeing the whole, acts as an overarching lens through which all other principles are viewed. It's the antidote to local optimization, which can often create inefficiencies for the entire system. Just as a single perfectly performing engine component doesn't make a good car if the brakes fail, optimizing individual parts of a software development process in isolation can degrade the performance of the overall system. Lean insists on systemic thinking, understanding the interconnectedness of every piece of the puzzle to optimize for total value delivery. The system view. Software development is not a collection of isolated tasks. It's a complex adaptive system. Every decision, every action, and every interaction within this system influences other parts. Understanding dependencies and interactions. A change in requirements affects development, testing, and deployment. A bottleneck in one team impacts the flow of work for downstream teams. Seeing the whole means recognizing these dependencies and designing solutions that improve the flow across organizational boundaries, rather than just within them. Avoiding local optimizations. A common pitfall is optimizing a component or a team's efficiency in isolation without considering its impact on the larger system. Example: a development team might become incredibly efficient at writing code, achieving high utilization of their time. But if that code sits in a queue waiting for manual testing or a security review for weeks, the overall system throughput, software delivered to the customer and generating value, remains slow. The local optimization simply shifts the bottleneck or even creates a bigger pile of inventory, partially done work, downstream in another part of the system. Focus on flow and throughput. The ultimate measure of a healthy lean system is its ability to deliver value continuously and quickly. This requires prioritizing the smooth, uninterrupted flow of work from concept to customer over individual resource utilization. Value stream from end to end, revisited. While we touched on value stream mapping in Chapter 3 to identify waste, seeing the whole extends this concept. It means having a complete, shared understanding of the entire value stream that delivers software, from the very first spark of an idea or a customer need, through design, development, testing, deployment, and even post-release operations and support. Identifying handoffs and queues. The biggest slowdowns in software value streams often occur at handoffs between different teams, roles, or even disparate tools and systems. Each handoff is a potential point of waiting, miscommunication, and loss of context. Seeing the whole means relentlessly working to reduce, automate, or streamline these handoffs to create a more continuous flow. The pipeline mental model. Think of software delivery as a continuous pipeline, not a series of disconnected steps. Any blockage or inefficiency in one part of the pipeline affects the entire flow, preventing value from reaching the customer. Organizational structures and silos. A significant barrier to seeing the whole often lies within traditional organizational structures. Functional silos, separate departments for product, development, quality assurance, operations, marketing, sales, naturally create boundaries and optimized handoffs that can impede end-to-end flow. The impact of silos. Each silo might optimize for its own metrics or goals, potentially at the expense of the overall system. For instance, a fast-track dev team might deliver code quickly, but if the ops team can't deploy it efficiently due to environment differences or manual processes, the customer still receives no benefit. Breaking down silos. Cross-functional teams revisited. As discussed in Chapter 6, bringing all necessary skills into a single, empowered team inherently breaks down many internal silos, fostering shared responsibility and a holistic view of the product. DevOps culture. A leading example of breaking down silos, this cultural and professional movement stresses collaboration and integration between software developers and IT operations professionals. It directly addresses the historical DevOps wall, aiming to automate and streamline the pipeline from development to production. Conway's Law, Melvin Conway's observation that organizations which design systems are constrained to produce designs which are copies of the communication structures of these organizations. To build well-integrated, flexible systems, you often need well-integrated, communicative teams. Seeing the whole acknowledges this fundamental observation and actively seeks to align organizational structure with the desired system architecture and flow. Optimizing flow, not utilization. This is perhaps the most counterintuitive aspect of Lean for many traditional managers, who equate busy resources with efficiency. The instinct is to keep every resource, e.g., developer, server, QA engineer, busy at 100% utilization. However, in a complex system like software development, high individual utilization frequently leads to slower overall throughput and increased lead times. Why overutilization hurts flow? When queues build up, due to teams being at 100% capacity, lead times increase, delays accumulate, and the system becomes less responsive to change. It's like trying to run maximum traffic through a choked highway. Individual cars might be going fast, but the overall throughput of cars through the entire highway decreases significantly. Lean recognizes that idle resources are sometimes necessary to keep the system flowing efficiently and adaptably. Focus on cycle time and lead time. Lean prioritizes optimizing the time it takes for a feature to move from idea to customer, lead time, and the time it takes to complete a specific task once active, cycle time, rather than solely focusing on how busy individuals are. Counterintuitively, allowing for some slack or slightly lower utilization often leads to better flow and faster overall delivery. Strategic alignment. Seeing the whole also extends to the strategic level. It means ensuring that every team's work, every feature delivered, contributes directly and clearly to the overarching business goals and vision of the organization. Transparent communication of vision. All teams, from individual contributors to senior leadership, must understand the company's overall direction, product strategy, and key priorities. This shared understanding minimizes misdirection and ensures efforts are aligned. Objective and key results, OKRs, or similar frameworks. Frameworks like OKRs provide a structured way to define and track objectives and their measurable key results at organizational, team, and individual levels. This helps align efforts across the entire organization, ensuring everyone is pulling in the same direction and understands how their work contributes to the whole. Supplier and customer ecosystems. The whole also explicitly includes entities external to the immediate development team or even the organization itself. External dependencies. Thinking about how third-party services, APIs, open-source components, or external partners are integrated into your value stream. Do they become bottlenecks? How can their processes be integrated or influenced to improve your overall flow? Customer feedback loops, truly end-to-end. Ensuring that insights from sales, marketing, customer support, and direct user feedback channels are not only collected, but also flow back efficiently and intelligently into the development process. This closes the loop on customer understanding and forms the basis for future product evolution. Leadership's role in seeing the whole. Leaders are pivotal in fostering this systemic view. They must break down departmental barriers, actively encourage cross-functional collaboration, shared ownership, and resource sharing, even if it requires reorganizing teams or changing reporting structures. Foster a shared understanding. Champion the consistent use of tools like value stream mapping to help everyone visualize and understand the end-to-end value stream and their specific role within it. Prioritize flow over local efficiency. Empower teams to make decisions that benefit the whole system's throughput, even if it means sacrificing a slight amount of local busyness for one team or component. Case study. Imagine Global Bank, a large, established financial institution struggling with long and unpredictable release cycles for its critical online banking platform. Development teams were productive, QA was thorough, and operations had robust deployment processes. However, each department operated within its own silo, with long handoffs, extensive documentation requirements, and conflicting priorities between them. The product backlog for the online platform was managed by a central product organization, which then handed off requirements to development. Development would code, pass to QA, who would pass to user acceptance testing, UAT, who would then pass to operations for deployment. Each handoff was a potential source of delay and misinterpretation. By applying the principle of seeing the whole and conducting a value stream mapping exercise for their entire release process, Global Bank realized that the biggest waste wasn't in coding time or testing time, but in the extensive waiting time and rework loops between these silos. Information was lost, context was misunderstood, and approvals took days or weeks. Their solution involved a massive organizational shift. They created autonomous, cross-functional value stream teams, each responsible for a specific customer-facing feature from ideation to production. These teams included product owners, developers, quality specialists, and operations engineers. They trained extensively on lean principles and adopted automated delivery pipelines that streamlined continuous integration, automated testing, and one-click deployments. This systemic change, moving from optimizing individual departments to optimizing the entire value stream, dramatically reduced their release cycle from quarterly or biannually to monthly, and eventually to weekly deployments. The result was faster response to market changes, improved customer satisfaction due to more frequent feature releases, and higher employee morale due to reduced frustration and a clearer sense of purpose. This transformation was only possible because leadership committed to seeing the whole and redesigned the organization to support that holistic view. The principle of seeing the whole reminds us that software development is an interconnected ecosystem. By understanding and optimizing this entire system, rather than just its individual components, organizations can achieve true agility, deliver continuous value, and maintain a sustainable competitive edge. With all 7 principles now understood, we can look towards applying them in practice. Chapter 8, Implementing Lean, Practical Strategies and Roadmaps. Understanding the 7 principles of lean software development is the crucial first step. The next, and perhaps most challenging, is translating those principles into real-world action. Lean is not a one-size-fits-all methodology. It's a philosophy that requires careful application and adaptation to your specific organizational context. This chapter will provide practical strategies and potential roadmaps for embarking on a lean transformation, acknowledging that it's a journey, not a fixed destination. Starting small, thinking big. Transforming an entire organization overnight is rarely successful. A big bang approach to lean adoption often encounters immense resistance, high costs, and a greater risk of failure. A more effective strategy is to pilot projects. Start with a small, self-contained, non-critical project or a single, willing team. This provides a safe, low-risk environment to experiment with lean principles and practices, learn what works and what doesn't in your unique context, and build crucial early momentum. Success here can become a powerful internal case study. Gradual adoption. Once the pilot proves successful, incrementally expand the lean approach to other teams or parts of the organization. This allows for continuous learning and adaptation of the implementation strategy itself, refining your approach based on real-world feedback rather than relying on theoretical plans. The inspect and adapt mindset for the transformation itself. Apply lean principles directly to your lean adoption journey. Regularly reflect on the progress of your transformation, identify what's helping or hindering, and adjust your approach. Treat the change process itself as a living, iterative project. Leadership buy-in and sponsorship. No significant organizational change succeeds without strong leadership support. Lean transformation is fundamentally about cultural change and process optimization, which requires sustained commitment from the top. Why it's crucial. Without visible and active leadership buy-in, teams attempting lean might face resistance from other departments, who don't understand the new approach, lack the necessary resources, or struggle to get cross-functional initiatives approved. Change efforts without executive sponsorship often wither on the vine. Leaders as facilitators and role models. Leaders must not only endorse lean, but actively participate, remove organizational impediments, communicate the why and vision frequently, and demonstrate lean behaviors themselves. They should be willing to challenge existing norms, empower their teams, as discussed in Chapter 6, and embrace the experimentation mindset. Communicating the why of lean. Clearly articulate the business benefits of adopting lean to all levels of the organization. Is it faster time to market, improved product quality, better employee retention, reduced operational costs? Tie the lean efforts directly to tangible business outcomes and strategic objectives, showing how lean is a means to achieve broader organizational success. Building a culture of continuous improvement, Kaizen. Lean is synonymous with Kaizen, the Japanese philosophy of continuous improvement. It's about instilling a mindset where everyone in the organization is constantly looking for ways to make things better, even if only incrementally. This isn't a one-time initiative, it's a permanent way of operating. Retrospectives. These are key to formalizing continuous improvement at the team level. Regular team meetings, e.g., bi-weekly or monthly, where teams reflect on their recent work period. They discuss what went well, to identify successes and reinforce positive behaviors. What could be improved, to identify problems and areas for growth. What will we commit to changing for next time? Crucially, creating concrete, actionable plans for improvement. The output of a retrospective should always be specific, actionable improvement items that the team commits to implementing. Gemba walks. A management technique where leaders go to the real place, the Gemba where work is being done. In software, this means observing a team during a stand-up, sitting with developers as they code, or watching a product owner interact with users. It's about direct observation and asking empathetic questions to understand daily challenges, not to critique or find fault. It provides invaluable context for managers to remove impediments. Experimentation mindset. Encourage teams to try new things, even small ones, and view failures as learning opportunities rather than punitive events. Fostering a fail-fast, learn-faster culture, as discussed in Chapter 4, Amplifying Learning, is essential for innovation and adaptation. Measuring what matters. While detailed metrics will be covered more in the next chapter, for continuous improvement, it's vital to measure flow, e.g., lead time, cycle time, quality, e.g., defect rates, customer satisfaction, and throughput. These metrics provide objective data for identifying where improvements are needed and for validating the impact of changes over time. Key enablers for lean adoption. Certain foundational elements significantly facilitate a lean transformation and support its principles. Training and education. Equip teams, managers, and stakeholders with a deep understanding of lean principles, specific tools, and their practical application to software development. Workshops, internal brown bags, online courses, and access to curated resources are vital to build capability and a shared language. Cross-functional team formation. Radically rethinking team structures to encompass all skills necessary to deliver value end-to-end. This supports the empower the team and seeing the whole principles by reducing handoffs and increasing collective ownership. This is often an iterative process, as organizations learn how to best assemble these teams. Automation. Relentlessly automate repetitive or error-prone tasks. This includes automated testing, continuous integration, continuous delivery, CI/CD, pipelines, infrastructure as code, and automated deployments. Automation reduces waste, delays, defects, manual effort, speeds up feedback loops, amplifying learning, and ensures quality, building integrity in. Visual management. Make work, progress, and problems visible to everyone. This fosters transparency and a shared understanding of the flow for all stakeholders. Kanban boards, physical or digital, dashboards displaying key metrics, like lead time trends, and information radiators are excellent tools for this, embodying the spirit of seeing the whole. Blameless culture. For true learning and improvement, particularly from incidents or process failures, teams must feel safe to admit mistakes and identify systemic issues without fear of individual blame. Blameless postmortems. Lessons learned sessions focusing on process and system, not people, are a prime example of this, reinforcing psychological safety and a learning culture. Addressing common implementation challenges. Embarking on a lean journey is not without its hurdles. Being aware of these common pitfalls can help organizations proactively address them. Resistance to change. This is natural. Some individuals may be comfortable with existing processes or fear losing control or relevance. Address this with clear, empathetic communication, involve people in the process, provide the necessary training and support, and consistently highlight the personal and organizational benefits of the new way of working. Maintaining momentum. Initial enthusiasm can sometimes wane after the early wins. Keep the why alive, celebrate small wins regularly, continuously show the benefits through data, and ensure leadership remains visibly committed and engaged in the lean journey. Scaling lean to large organizations. As an organization grows, applying lean principles beyond a few teams can become complex. While frameworks like SAFe, Scaled Agile Framework, LaSS, Large-Scale Scrum, or DIDI, Disciplined Agile Delivery, exist, the core challenge is to ensure the principles, e.g., end-to-end value streams across multiple teams, shared vision, fast feedback at scale, are adapted to the specific organizational context, rather than rigidly implementing a framework without understanding its underlying purpose. Balancing innovation with stability. Lean, especially through deciding late, encourages rapid experimentation. However, some systems, particularly in highly regulated industries or mission-critical contexts, require high levels of stability and predictability. Organizations must learn how to balance innovation and rapid delivery in some areas with meticulous reliability and robust processes in others. Measuring success beyond just speed. While speed to market is a key benefit, true lean success encompasses a holistic view. Quality, customer satisfaction, employee engagement and retention, and overall business value. Don't fall into the trap of optimizing for speed alone, which can lead to sacrificing quality or accumulating unsustainable technical debt. Ignoring technical debt. A common anti-pattern is pushing for speed without addressing accumulating technical debt, poorly designed or suboptimal code and systems. If not managed and continuously refactored, a key practice for building integrity in, this debt will inevitably slow down future development, increase defects, and eventually grind progress to a halt. Sample roadmap, iterative approach. A typical lean adoption might follow these iterative steps. Remember, this is a guide, not a rigid prescription. Your specific path will be unique. Awareness and vision alignment. Senior leadership educates themselves on lean and communicates a clear why for the transformation. Identify a pilot area or team willing to champion the change. Provide initial lean training. Understand current state, value stream mapping. The pilot team performs a focused value stream map of their current process for a key product or feature, as detailed in Chapter 3.9. Collect data to identify major wastes, bottlenecks, and delays. Implement basic flow mechanisms. Set up a visible Kanban board, physical or digital, for the pilot team to visualize their workflow. Implement initial work in progress WIP, limits based on the VSM observations to reduce partially done work. Start daily stand-ups to coordinate work and identify immediate blockers. Strengthen feedback loops and basic automation. Focus on automating one key feedback loop, e.g., set up continuous integration with basic automated unit tests. Begin collecting basic flow metrics, lead time, cycle time, to provide objective data for improvement, as hinted in Chapter 4. Routine reflection and improvement, Kaizen. Initiate regular team retrospectives, committing to concrete improvements each cycle, e.g., every 2 weeks. Start incorporating refactoring regularly to address technical debt and maintain code health. Expand and iterate. Once the pilot team sees initial success and demonstrates tangible benefits, share learnings widely through internal presentations, success stories, and open houses. Expand to another team or another part of the value stream, repeating the process and adapting based on prior learnings. Continuously refine and deepen lean practices, e.g., introduce TDD, BDD, full continuous delivery, more advanced monitoring. Case study: Innovate Software, a mid-sized enterprise software company, was plagued by slow release cycles and frequent post-release bugs for their flagship product. They decided to implement Lean on one of their smaller internal tools as a pilot. They began with a value stream map workshop, revealing significant delays in their manual testing and deployment processes, and a huge backlog of partially done features. This exercise, consistent with eliminating waste and seeing the whole, immediately clarified their biggest pain points. They then formed a dedicated, cross-functional team for this internal tool, empowering them with autonomy. This team, embodying Empower the Team, adopted a Kanban board with strict WIP limits, reducing their partially done work waste. They invested heavily in automating their test suite and deployment pipeline, embracing, delivering fast, and building integrity in. Within 3 months, they reduced their release cycle for that internal tool from monthly to daily, leading to faster feedback from internal users and a more engaged, less frustrated team. Their defect rate plummeted. This demonstrable success story then became the blueprint and inspiration for other teams across InventSoft to begin their own iterative lean transformations, showing the power of starting small and thinking big. Implementing lean is a journey of continuous improvement. It requires patience, persistence, and a willingness to learn and adapt. The specific tools and practices that enable this journey are the subject of our next chapter. Chapter 9. Lean Tools and Practices in Action. The principles of lean software development provide the conceptual framework, the why. To put these principles into practice, we rely on a set of powerful tools and specific practices. These aren't just arbitrary methodologies. Each one directly embodies one or more lean principles, helping teams eliminate waste, amplify learning, build quality in, and accelerate delivery. This chapter will delve into some of the most impactful lean-aligned tools and practices used in modern software development. Value Stream Mapping, VSM, the diagnostic lens. While introduced in Chapter 3 as a way to identify waste, Value Stream Mapping, VSM, is also a crucial tool for seeing the whole, Chapter 7, and amplifying learning, Chapter 4. It serves as a diagnostic lens to understand the current state of your software delivery process and to envision a more efficient future state. Purpose: to visually represent every step involved in delivering a product or service to the customer, from concept to final delivery. This visualization helps to distinguish value-adding steps from non-value-adding waste. Process: VSM is typically conducted as a collaborative workshop involving all key stakeholders who touch the value stream, e.g., product owners, developers, testers, operations, business representatives. Define the scope. Clearly identify the specific product, feature, or service whose delivery process you intend to map. Map the current state. Step by step, participants map out every activity, decision point, handoff, queue, and rework loop that work goes through. For each step, critical data is collected. Process time, PT, the actual time spent doing value-adding work, e.g., actual hours coding. Lead time, LT, the total time an item spends in that stage, including waiting, handoffs, and actual work. Queue time, QT, the time an item spends idle, waiting to be worked on. Quality, any percentage of defects or rework associated with that step. Visualize, use standardized symbols or simple shapes to draw the map, showing the flow of information and goods or software increments. Often, swim lanes are used to represent different teams or departments. Calculate total times. Sum up all the process times to get the total value-added time. Sum up all the lead times to get the total end-to-end cycle time. The often vast difference between these two totals graphically represents the amount of waste in the system. Identify bottlenecks and waste. Visually obvious cues, disproportionately long lead times relative to actual process times, and frequent rework loops are highlighted as prime targets for improvement. Design the future state. Based on the identified waste, the team brainstorms and maps an ideal, more efficient process, proposing concrete ways to eliminate waste and improve flow. Output: a clear visual understanding of where delays and waste exist, a strong shared understanding of the entire value stream, and a prioritized list of actionable improvements to guide transformation efforts. Kanban and flow management, the visual control system. Kanban, adapted from Toyota's signaling system, is a method for managing and improving the flow of work. It directly supports eliminating waste, Chapter 3, by limiting work in progress WIP, and helps to deliver as fast as possible, Chapter 5, by optimizing flow. The Kanban method origin. Taiichi Ono developed Kanban Japanese for visual signal or card to manage production in Toyota factories. Instead of pushing work through, Kanban uses cards to signal when new work or parts are needed downstream, creating a pull system. This significantly reduced overproduction and inventory waste. Core concepts in software development. Visualize workflow. Use a Kanban board, physical whiteboard, or digital tool like Jira or Trello with columns representing distinct stages of your workflow, e.g., backlog, ready for development, in development, code review, testing, deployed. Each work item, e.g., a feature, user story, or bug fix, is represented by a card moving across the board. Limit work in progress, WIP. This is the cornerstone. Set a strict maximum number of items that can be in each in progress stage at any given time. This forces the team to focus on finishing what they've started before beginning new work, directly combating the waste of partially done work. Manage flow. The primary focus shifts from keeping individuals busy to moving items smoothly from left to right across the board. When a column approaches its WIP limit, it signals a bottleneck, prompting the team to swarm on that work item or stage to resolve the blockage. Make policies explicit. Clearly define what done means for each column, how items move between stages, and other rules governing the workflow. This promotes consistency and clarity. Implement feedback loops. Regularly review the board, e.g., during a daily stand-up, discuss blockers, and use metrics for continuous improvement. Key metrics for flow. Kanban naturally generates data for powerful flow metrics. Lead time. The total time from when an item is requested by the customer until it's delivered to the customer. Cycle time. The time it takes for an item to move from start work to done within a specific part of the workflow. Throughput. The number of items completed per unit of time, e.g., features deployed per week. Benefit. Provides immediate visual visibility into workflow, highlights bottlenecks and delays, and enables continuous improvement of flow to deliver value faster and more predictably. Test-driven development, TDD, and behavior-driven development, BDD. Anchoring quality and learning. These practices directly fulfill the principles of building integrity in Chapter 6 and amplifying learning, Chapter 4. They shift quality left, embedding it throughout the development process rather than bolting it on at the end. Test-driven development, TDD. Process. TDD is a software development approach where tests are written before the production code. It follows a rapid, iterative red-green refactor cycle. Red, write a small, automated test for a desired piece of new functionality or a bug fix. This test should initially fail because the functionality doesn't exist yet. Green, write just enough production code to make the failing test pass. No more, no less. Refactor. Improve the code's internal structure, design, and readability while ensuring all tests, new and old, continue to pass. Benefits. Guarantees comprehensive test coverage, acts as executable documentation of the code's intended behavior, forces developers to think about good design. Testable code is often well-designed code. Reduces defects significantly by catching them early, and increases developer confidence in making changes to the codebase. Behavior-driven development, BDD. Process. BDD extends TDD by emphasizing writing tests around the behavior of the system from the perspective of its users or stakeholders. It often uses a clear, human-readable language, like Gherkin syntax, given context when event, then outcome, to specify requirements, which can then be automated as tests. Benefits. Improves collaboration and communication between developers, testers, and product owners, business analysts, by creating a shared understanding of requirements. Clarifies expectations, and drives development using real business value and user needs. Continuous integration, CI, and continuous delivery deployment, CD, accelerating flow and feedback. These practices are fundamental enablers for delivering as fast as possible, Chapter 5, and amplifying learning, Chapter 4, by ensuring a continuous, automated flow of code from development to production. Continuous integration, CI. Practice. Developers frequently merge their code changes, ideally many times a day, into a shared main branch in a central repository. An automated build server immediately compiles the code and runs a comprehensive suite of automated tests. Benefits: rapidly detects integration issues and regressions, provides fast feedback to developers if a change breaks anything, avoids integration hell, where large, infrequent merges lead to chaotic bug fixes, and ensures the codebase is always in a working, potentially releasable state. Continuous delivery, CD. Practice: building on CI, CD extends the automated pipeline to create deployable artifacts, e.g., packaged applications, and run further automated tests, e.g., performance, security, end-to-end tests in staging or pre-production environments. The system is always ready to be deployed to production at any time, usually by a simple manual trigger. Benefits: lowers the risk of releases significantly, makes releases a routine and low-stress event, and dramatically accelerates time to market for new features or bug fixes. Continuous deployment, CDP. Practice: an extension of CD where every change that successfully passes all automated tests in the pipeline, including those for CI and CD, is automatically deployed to production without human intervention. Benefits: achieves maximum speed of delivery, provides immediate feedback from real users in a production environment, and forces extreme automation and quality practices due to the lack of manual gatekeepers. Small batches and incremental development, reducing waste, increasing speed. This practice is a direct application of delivering as fast as possible, Chapter 5, and directly helps in eliminating waste, Chapter 3, specifically partially done work and extra features. Practice: instead of developing large, complete features over extended periods, which tie up resources as inventory, break down work into the smallest possible vertical slices of functionality that still deliver value to the customer. Vertical slicing. A vertical slice means delivering a small, end-to-end piece of functionality that moves through all necessary layers of the system architecture, e.g., from the user interface through business logic to the database and back. It's a complete, working, testable piece of value. Benefits: reduces the amount of work in progress at any given time, accelerates feedback from users who can try out the partial feature early, minimizes risk, easier to detect and fix issues in small increments, allows for early return on investment, and fosters faster learning cycles based on real user interaction. The power of automation, the engine of Lean. Automation underpins almost every successful Lean practice, serving all 7 principles by eliminating manual waste, speeding up processes, and improving reliability. Why it's essential. Manual tasks are prone to human error, are slow, inconsistent, and require constant human attention, consuming valuable intellectual capital. Automation removes this toil, ensures consistency, and provides immediate, objective feedback. Examples: automated testing, as discussed with TDD, BDD, and CI. This is arguably the most critical area for automation in software development. Infrastructure as code, ISC, managing and provisioning computing infrastructure, networks, virtual machines, containers, through machine-readable definition files, rather than manual hardware configuration or operating system setup. Ensures environments are consistent, reproducible, and can be provisioned quickly, eliminating the waste of delays and relearning. Automated deployments. As part of CD/CDP, ensures software reaches production quickly and reliably, often with zero downtime, reducing delays and human error. Automated code analysis. Tools that automatically check code for potential errors, style violations, security vulnerabilities, or adherence to coding standards. This helps build integrity in without requiring manual review for every detail. Visual management, beyond Kanban, transparency for the whole team. This practice strongly supports seeing the whole, Chapter 7, and amplifying learning, Chapter 4, by making work transparent, progress visible, and problems easily understood by everyone. Practice, creating highly visible displays that provide real-time information about workflow, progress, problems, and performance metrics. These can be physical whiteboards or large digital screens. Examples: information radiators, large display screens, or shared digital dashboards for remote teams, prominently showing key metrics like build status, red-green, latest deployment success rates, current work in progress WIP on a Kanban board, lead time trends, or critical operational metrics for a live system. Burn down, burn up charts, visualizing progress towards a goal burn down or the completion of work over time burn up. These help track predictability and highlight deviations from planned progress. Team dashboards, customizable dashboards pulling data from various tools, issue trackers, CI/CD systems, monitoring tools to give a holistic, real-time view of the team's health and progress. Benefits: foster shared awareness across the team and stakeholders, highlight bottlenecks and blockers at a glance, promote self-organization, as teams can see where help is needed, and enable quicker, data-informed decision-making. Practical example: consider a software team at Streamline Solutions, a company building a new financial management platform. Their journey began with a value stream mapping session, VSM, that revealed significant waiting times in code review and manual deployments. Armed with this insight, they implemented a digital Kanban board with a strict WIP limit for in-code review, eliminating waste. Their daily stand-up begins with reviewing the board, quickly identifying any cards stuck in bottlenecks, managing flow. For a new feature, like instant expense reporting, they start with a BDD session, defining the behavior in clear given-when-then scenarios. These scenarios are then turned into automated tests that form the foundation of their TDD process. Developers write failing tests, then just enough code to make them pass, and then refactor, building integrity in. Code changes are committed frequently to their main branch, triggering a fast, continuous integration build that runs all automated tests. If any test fails, an information radiator on the team's dashboard immediately turns red, alerting everyone to the issue, enabling rapid feedback. Once the feature is complete and all tests pass locally and in CI, their continuous delivery pipeline automatically deploys it to a staging environment for final review. When approved, it's a single click, or often fully automated in CDP fashion, to deploy to production, where real-time dashboards show usage and performance metrics, amplifying learning and delivering fast. This seamless, automated flow, supported by constant visual feedback, allows Streamline Solutions to deliver valuable features quickly, with high quality, and without internal friction. These tools and practices are not ends in themselves, but powerful means to achieve the underlying lean principles. They are the concrete actions and methodologies that bring the philosophy of lean software development to life, paving the way for sustainable success and an adaptable future. Chapter 10, Beyond the Code, Sustaining a Lean Culture and the Future of Software. We have journeyed from the factory floors of Toyota to the intricate craft of software development, exploring the 7 principles of lean and the powerful tools that bring them to life. By now, it should be clear that lean software development is far more than a set of practices. It's a living philosophy, a continuous journey of improvement that impacts not just how we write code, but how entire organizations function. This final chapter will address the critical challenge of sustaining a lean culture, highlight common pitfalls to avoid, and speculate on the evolving role of lean in the future of technology. Sustaining the lean culture. Implementing lean is an initial push. Sustaining it is a marathon. It requires ongoing discipline, leadership commitment, and a deep-seated belief in continuous improvement baked into the very fabric of the organization. Leadership commitment as an ongoing force. Initial leadership buy-in is vital, but sustained, active commitment is paramount. Leaders must continue to champion lean principles, regularly communicate the why behind the transformation, celebrate successes authentically, and most importantly, lead by example. This means being visible, actively removing organizational impediments, genuinely empowering teams, and demonstrating the experimentation and learning mindset themselves. Their consistent support signals that lean is not a passing fad, but a strategic imperative. Continuous learning and adaptation, Kaizen never ends. The world of technology is constantly evolving. A truly lean organization never rests on its laurels. It embeds Kaizen, the relentless pursuit of small, incremental improvements, into its very DNA. This means regular retrospectives, Chapter 8, are non-negotiable forums for team-level learning and action. New tools and technologies are evaluated based on their ability to embody lean principles and improve flow, rather than just their novelty. Processes are routinely challenged and refined, ensuring they remain fit for purpose as the context changes. Measuring what matters, again, the focus on metrics must be revisited frequently. Are you still measuring what truly indicates value, flow, and quality? Are you looking beyond just raw speed to include customer satisfaction, system reliability, and team morale? Avoid the trap of vanity metrics that look good but don't drive meaningful improvement. Metrics should always inform learning and process adjustments. Celebrating successes, learning from failures. A lean culture thrives on positive reinforcement and psychological safety. Celebrate milestones, small wins, and successful improvements to reinforce desired behaviors. When failures or setbacks occur, and they inevitably will treat them as invaluable learning opportunities. Conduct blameless postmortems, as discussed in Chapter 4, to understand the systemic causes, apply lessons learned throughout the organization, and foster a culture where experimentation, even if it leads to failing fast, leads to faster, deeper learning. Onboarding new team members. Integrate lean principles and the organizational culture of continuous improvement into your onboarding process. New hires should understand how the organization works, the importance of continuous improvement, and the contribution of their role to the overall value stream. This ensures the culture is perpetuated and strengthened with each new addition. Challenges and pitfalls to watch out for. The path to lean maturity is fraught with common traps that can derail even the most well-intentioned efforts. Cargo cult lean. This is a pervasive anti-pattern. It occurs when organizations adopt the practices, e.g., daily stand-ups, Kanban boards, 2-week iterations, without understanding the underlying principles, like eliminating waste, amplifying learning, building integrity in, and their true purpose. They go through the motions and perform the rituals without internalizing the why, leading to superficial change that doesn't deliver real, sustainable results. The antidote is constant education, and by always asking why behind every practice. Managerial resistance. Some managers, especially those accustomed to traditional command and control structures, may feel threatened by the empowerment of teams, the increased transparency, or the shift from directive roles to servant leadership. They might fear losing control or relevance. Addressing this requires empathy, targeted education, clear communication about new roles, and demonstrating how lean actually makes their work easier and more impactful by leveraging the collective intelligence of their teams. Over-reliance on tools. Tools like Jira, GitLab, Azure DevOps, or specialized VSM software are powerful enablers, but they are not a substitute for understanding lean principles. A sophisticated tool used with a non-lean mindset can still embed waste and inefficiency. Focus on the process and culture first, then choose tools that genuinely support and amplify the adopted lean principles and practices. Ignoring technical debt. The pressure to deliver quickly, if not tempered by a commitment to quality, can lead to aggressive accumulation of technical debt, suboptimal code, poor architecture, lack of automated tests. This debt acts like concrete in your gears, eventually slowing down future development, increasing defects, and leading to developer burnout. Lean, with its emphasis on building integrity in Chapter 6 and continuous refactoring, explicitly positions managing technical debt as an essential, ongoing investment. Burnout. While lean aims for sustainable development, aggressive interpretations of deliver as fast as possible can lead to excessive pressure and burnout. Lean's focus on flow and pull systems, limiting work in progress and not pushing more work onto overloaded teams, is crucial to maintaining a sustainable pace and fostering work-life balance for teams. A healthy lean system prioritizes long-term vitality over short-term, unsustainable bursts of activity. The future of lean software development. The core principles of lean are enduring because they address fundamental truths about efficiency, value creation, and human collaboration. As technology continues its relentless evolution, lean will continue to adapt and find new applications. AI and machine learning as lean enablers. AI and ML are not just things we build. They are becoming powerful tools to enhance lean processes. Predictive analytics. AI can analyze vast amounts of data from your pipelines and systems to predict bottlenecks, identify process inefficiencies, and suggest optimal improvements in the software development lifecycle. Intelligent automation. Beyond simple robotic process automation, RPA, AI can automate more complex development and operational tasks, from intelligent code generation and refactoring suggestions based on patterns, to advanced monitoring and proactive incident response in production. Enhanced learning. AI can help analyze customer usage data faster and with deeper insights, providing even quicker feedback loops for product learning and adaptation, effectively amplifying learning at scale. Platform engineering's role. The rise of platform engineering in enterprises strongly aligns with Lean. It's about building internal development platforms that provide self-service capabilities for common, repetitive tasks, e.g., provisioning infrastructure, setting up CI/CD pipelines, deploying services securely. This directly reduces waiting and handoffs. Waste empowers development teams, empowering the team, and accelerates overall delivery, delivering fast by making common, foundational tasks frictionless. The enduring human element. As AI takes on more repetitive or analytical tasks, the Lean emphasis on human creativity, collaboration, critical thinking, and problem-solving within empowered teams will become even more pronounced. The unique human ability to see the whole Chapter 7, to understand complex problems in their full context, to innovate, and to collaborate on adaptive solutions will remain paramount and ever more valuable. Beyond software. The principles of Lean, already widely adopted in other industries, continue to find relevance even beyond the immediate confines of software departments. Agile and Lean philosophies intersect heavily in areas like product management, Lean UX, Lean startup, marketing campaigns, sales processes, and general business process improvement. The mindset of identifying value and relentlessly eliminating waste, while fostering continuous learning, is universally applicable to any knowledge work discipline. Final thoughts. Lean as a mindset. Ultimately, Lean software development is more than a methodology, it's a mindset. It's a way of thinking about how we create, how we deliver, and how we continuously improve. It's about obsessing over customer value, relentlessly eliminating everything that doesn't add value, fostering a culture where learning, experimenting, and adapting are continuous, actively empowering the people closest to the work, always seeing the big picture and optimizing the whole system. The journey to become a truly Lean software organization is challenging but immensely rewarding. It leads to higher quality products, faster delivery cycles, more engaged and happier teams, and ultimately, a more adaptable and successful business capable of thriving in an ever-changing world. This book has provided the roadmap and the foundational knowledge. The next step is yours. Embrace the Lean mindset, start small, and embark on your own journey of building better software, faster, and more sustainably.